Good day, viewers! Our group assigned each one of them to explain a specific topic in statistics and probability. And the topics that assigned to me is to explain what is sampling techniques and what are the probability and non-probability sampling methods. Sampling is a technique of selecting individual members or a subset of the population to make statistical inferences from them. And also, it estimates characteristic of the whole population. When you conduct research about a group of people, it's rarely possible to collect data from every person in that group. Instead, you select a sample. Yung pinaka-sample dito is yung tao na napili mo sa isang specific group na makakatulong or makakapag-participate sa research mo. So, there are two types of sampling methods. It is the probability sampling and the non-probability sampling. So, first, what is probability sampling? It involves random selection, allowing you to make strong statistical inferences about the whole group. So, what is non-probability sampling? It involves non-random selection based on convenience or other criteria, allowing you to easily collect the data. First, you need to understand what is the difference of a population and a sample. The population is the entire group that you want to draw conclusions about. But in sample, it is the specific group of individuals that you will collect data from. So from the word entire group do sa population, it means lahat kayo, walang matitira. So from the word naman specific group dun sa sample, may mga kukunin lang kayong participants or may mga pipiliin lang kayong tao dun sa population. So let's proceed to the probability sampling methods. Probability sampling means that every member of the population has a chance of being selected. It is mainly used in quantitative research. If you want to produce results that are representative of the whole population, probability sampling techniques are the most valid choice. So there are four main types of probability sample. So the first one is simple random sampling. In a simple random sample, every member of the population has an equal chance of being selected. Your sampling frame should include the whole population. The second one is systematic sampling. It's similar to simple random sampling, but is usually slightly easier to conduct. Every member of the population is listed with a number, but instead of randomly generating numbers, individuals are chosen at regular intervals. So the third is stratified sampling. Stratified sampling involves dividing the population into subpopulations that may differ in important ways. It allows you to draw more precise conclusions by ensuring that every subgroup is properly represented in the sample. To use this sampling method, you divide the population into subgroups called strat based on the relevant characteristics. Example, gender, age, range, income bracket, job, or role. The last one is cluster sampling. It also involves dividing the population into subgroups, but each subgroup should have similar characteristics to the whole sample. Instead of sampling individuals from each subgroup, you randomly select entire subgroups. So let's proceed to the non-probability sampling methods. In a non-probability sample, individuals are selected based on a non-random criteria, and not every individual has a chance of being included. So there are four main types of non-probability sample. So the first one is convenience sampling. A convenience sample simply includes the individuals who happen to be most accessible to the researcher. The second one is voluntary response sampling. It's mainly based on the ease of success. Instead of researcher choosing participants and directly contacting them, people volunteer themselves. The third one is purposive sampling. This type of sampling, also known as judgment sampling, involves the researcher using their expertise to select a sampling that is most useful to the purposes of the researcher. And the last one is snowball sampling. If the population is hard to access, snowball sampling can be used to recruit participants via other participants. The number of people you have to access to snowballs as you get in contact with more people.
So today I'm going to show you an example of simple random sample. But first, what is simple random sampling? In a simple random sample, every member of the population has an equal chance of being selected. Your sampling frame should include the whole population. To conduct this type of sampling, you can use tools like random number generators or other techniques that are based entirely on chance. An example of simple random sample would be the names of 25 employees being chosen out of a hat from a company of 250 employees. In this case, the population is all 250 employees and the sample is random because each employee has an equal chance of being chosen. So that is an example of simple random sample.
population, sample, parameter, and statistics. Population: all the data, observations, responses, measurements, etc. of interest in a study. Sample is a subset of the population. Parameter, a number that describes the data from a population. Statistics, a number that describes the data from a sample. These are some of the examples of population, sample, parameter, and statistics. Number 1. The average of 50 randomly selected registered vehicles from the New York Bureau of Motor Vehicles was 8 years. Here, the population is the ages of all vehicles registered with the NYBMV, and the sample is the ages of the 50 randomly selected vehicles. The parameter is the average age of all registered NY vehicles, and the statistic is the average age of the 50 randomly selected one. Example number 2. The median household income in the United States in 2018 was $63,937. In Chicago, a study found the median household income to be $70,760. Here, the population is the incomes of all households in the United States in 2018, and the sample is the incomes of households in Chicago in 2018. The number $63,937 is a parameter, and the number $70,760 is the statistics. Population and sample examples. Number 1. In a political poll, a company contacts 1,200 registered voters at random and asks whom they intend to vote for. The sample is the list of preferences. The population is the list of preferences of all registered voters. It's usually impractical to collect population data. The point of inferential statistics is to draw conclusions about the populations from sample data.